On to level 5.5, which is a big section in this chapter, all on properties of logs. So this is where you might have seen logs last year or previously, where people say logs are these ridiculous things and I don't understand what's going on. So hopefully this section will alleviate some things and we'll definitely get a lot of practice with working with logs. So before we even begin, the basic properties of logs. Log base A of 1 will always be 0. Again, if you remember Bay, then that makes sense. A to the 0th power is always 1. Same thing, log base A of A equals 1, which is again saying A to the 1st equals A. So if you have the log of the same thing, then that is just 1. If you remember those two, then it makes your life a lot easier. So the next two that we're going to add. If you have an exponent that's a log, then these two cancel each other out. So A to the log base A of something, these two cancel each other out and you're just left with that something. Because again, if we wanted to show this, we could always put this in log base form. So log base A of M equals log base A of M, so M equals M. Likewise, if we have log base A of A to the R, so the reverse. So the bases are the same and we have an exponent, then it's just the exponent, because what we'll see is if we move that out front, then this would just be 1 and we'd be left with the exponent. All right, so in practicality, 2 to the log base 2. These two cancel out and you're left with just pi. Log base 0.2 of 0.2 to the negative root 2. These two cancel out and you're just left with negative root 2. ln of e to the kt. Remember, ln is log base e, so this is base e of e to the kt. So this is just kt. And 5 to the log base 5 of 6 plus log base 5 of 7. We have to do a little bit of work here. Remember, if you add exponents, it's like multiplying like bases. So 5 times log base 5 of 6 times 5 log base 5 of 7. Well, like these cancel, you have 6 times 7, that cancels, which is just 42. And this multiplication thing will come back when we see the next section. So the next set of rules that we're going to add. If you have two things inside a log, we can separate that multiplication out into addition, because if we have like bases, then we add the exponents. For multiplying like bases, we add the exponents. So same thing. If we're multiplying two things, we can separate it out into two additions. Likewise, if we're dividing two things, then division turns into subtraction. And then if we have an exponent, then we are just going to slide that exponent in front, because that's our copies of log base A of M. So multiplication turns into addition, division turns into subtraction, and exponents go in front. All right, so flip it over. We're going to get to some problems. All right, example 2. Write as the sum of logs, and there should be a parenthesis there. So remember, log, just as a general, means log base 10. So we have multiplication here. We have log of x times x squared plus 1 to the 1/2 power. Okay, and this is all in parentheses. I just wanted to rewrite that for us. So with that multiplication, I can separate that out into addition. I also have this exponent here, so I'm going to move that exponent out front. So that's log of x plus 1/2 log of x squared plus 1. Because this is addition, we can't separate any further. So we can't separate addition or subtraction, and that's the most rookie mistake people make when they're dealing with logs, because they just keep wanting to separate everything. So let's try another one. Write ln of x squared over x minus 1 cubed as the difference of logs. So again, this is division, so we can separate that out into subtraction. So we're subtracting these two quantities. Now we've got exponents, so they just slide to the front. And that's how we separate these, and then we deal with the exponents last. So what if we have the sum and difference of a couple things? Well, first, we're going to separate these out, and I'm also going to write that square root as an exponent. So we're going to have log of x squared plus 1 to the 1/2 minus the log of x squared times x plus 1 to the 4th. Now this, we can have 1/2 log of x squared plus 1, and this is minus, okay, and I'm going to put parentheses here because I want to distribute that negative. This is log of x squared plus, because these are multiplication, log of x plus 1 to the 4th. Now the last step, I can slide this exponent in front, slide this exponent in front, and I'm going to distribute this negative. So I have 1/2 log of x squared plus 1 minus 2 log x minus 4 log x plus 1. And that's how we can write this all with sums and differences. Last one, expanding this out. We have multiplication on the top, division on the bottom. So this is ln of x squared times y cubed minus ln of z to the 4th. Now I can separate this into addition. So that's the ln of x squared plus the ln of y cubed minus ln of z to the 4th. And the last bit, we move the exponents in front. So 2 ln of x plus 3 ln of y minus 4 ln of z. So that is separating. The next one, we're going to take one of these expressions and bring it down into one thing. So with example 3, we're writing these as a single expression. So these are going to be expanded out, and we want to make them one thing. So the first thing is we move all of the exponents back. So we have log 7, so that's log base 10 of 7, plus log 3 to the 4th. Now I could figure out what 3 to the 4th is, it's 81, but for our purposes, I'm just going to leave it. So now we have addition, so it turns into multiplication. So that's log of 7 times 3 to the 4th. So this would be our answer. Now obviously that is also 7 times 81. So 7 times 8 is 56. So 567. So realistically, if you had a calculator, this would be the log of 567. Now, next one. First things first, we move the exponents in front if we can. So that is the ln of 8 to the 2/3 minus ln of 3 to the 4th minus 8. So we can do that math. 3 to the 4th is 81 minus 8 is 73. This we can do. So we can simplify those because they're in parentheses. Now 8 to the 2/3 is 8 squared cubed root. So 8 squared is 64. The cube root of 64 is 4. So this is really ln of 4 minus the ln 73. That subtraction becomes division. So then ln of 4 over 73. And that is written as 1 log. Next up, how about if we have some variables? That'd be nice. First, if we have any exponents in front, we move them. We don't. Obviously, they're all the same base, so we can combine these. So multiplication, multiplication. So we have log of 9x, x squared plus 1, minus log of 5. This is all of the addition turns into multiplication. Then subtraction becomes division. So this would be log of 9x, x squared plus 1, all over 5. And this is simplified. Last up, we have the same base here. So first the exponents go back up. So that's log base 2 of u cubed plus log base 2 of v to the fourth. And then addition becomes multiplication. So we have log base 2 of u cubed v to the fourth. Last one. Exponents go up first. So this is log of x plus 1 squared minus. Now I see that these both have a negative, so I can factor a negative 1 out. And this is, again, where people have problems seeing both negatives, so that means they would both be in the denominator. So now we have multiplication here, so that is x plus 1 squared minus log of x plus 3 x minus 1, because addition turns into multiplication, and then subtraction becomes division, so we have log of x plus 1 squared over x plus 3 x minus 1. Now when you get good at this, you don't have to do all these intermediate steps. You can just jump to the end. All right, flip it over. Last property of logs that we really want to talk about is something called the change of base formula. Now, before we had super fancy calculators like the ones we have, where we could just choose any of our base, in order to figure out a log of something that's not log base e or log base 10, and using tables, we would use a change of base formula. So what this says, if we have log base a of m, and we want to change the base to whatever we want, we always put the base on the bottom, so whatever we choose, log base b, our new base, of m divided by log base b of a, which a was our original base. A is original. And that goes on the bottom. So, like I said, since our calculators only have log and ln, especially if you're just using your phone, in practice, change of the base usually looks like either log m over log a or ln of m divided by ln of a. So it says approximate, and I'm going to show on our calculators. So let me get mine out, and I'll make a new document. So, calculator. We're going to add a calculator, and then first off, log base 2 of 7. So if we change our base to ln, it's going to be the ln of 7 divided by the ln of 2. And if we approximate to 3 decimals, and I do, fraction, ln 7 divided by ln of 2, enter, and then I had to control enter to get my decimal. So that is 2.807. Likewise, approximate log base 5 of 89. We could do, if we don't want ln, we can do log base 10 of 89 divided by log base 10 of 5. So I'll show you that we can do log base 10. And you see, when I used my calculator here, I just zoom in a little bit, you can see that I have a base that I can choose. So if I already know that's 5 and 89, and I hit enter, I get about 2.788. Now if I do my normal change of base, so I'm just going to type in 10 of 89 divided by log base 10 of 5, we should get the exact same thing. So 2.789. Likewise, let's zoom back out just a little bit. If we're approximating log of square root of 2 of square root of 5, we can easily write that the ln of square root of 5 divided by the ln square root of 2. And that's a lot easier to calculate. So ln, before I do that, get my fraction, ln of the square root of 5 divided by the ln of the square root of 2. Now my general one that I go to is usually ln. It's just easier, don't have to change a lot of things. 2.322. So just as a summary, all of the things that I expect you to know, how to go from logs to exponents or exponents to logs. So know your bay. Then anything, log base anything of 1 is 0. Log base a of itself is 1. Exponents go in front. If we have a to the log base a of m or log base a of a to the r, both of these cancel each other out. Multiplication becomes addition. Division becomes subtraction and vice versa. And then change of base. So I know it's a lot, and there's quite a number of problems here for us to practice. We'll get the hang of it.